SpaceX successfully launched its second rocket of the year on January 13 as one of its veteran boosters carried dozens of satellites into orbit before landing back on Earth. The rocket lifted off as planned from Cape Canaveral Space Force Station Launch Complex 40 on Thursday, with 105 small satellites in tow, marking SpaceX's third dedicated small-sat rideshare mission since January 2021. Approximately 9 minutes after launch, the first stage booster landed at the company's landing zone 1 at Cape Canaveral, marking the first land landing of a Falcon 9 booster since the Transporter 2 rideshare mission in June 2021. The booster, B1058, was on its 10th flight, having first launched in May 2020 on the Demo 2 commercial crew mission for NASA. On its way to orbit, the second stage performed a dogleg maneuver to keep its heading slightly west of due south to reach its desired orbital inclination while avoiding flight over populated areas. Around 55 minutes after liftoff, the upper stage began deploying its payloads into a 525-kilometer sun-synchronous orbit. It took approximately an hour and a half for all the passengers to deploy from the upper stage. On board this mission was a plethora of small satellite payloads. The largest single customer, in terms of the number of spacecraft, was Earth observation company Planet, which flew 44 Super Dove spacecraft. The biggest of the group was the Ukrainian Sich-2-1 satellite, a 170-kilogram Earth imaging satellite for the Ukrainian government. The Transporter 3 rideshare mission was facilitated by companies like Spaceflight Incorporated and Exalaunch, which help small satellites customers book their perfect ride to space. While relatively insignificant in the scope of the rest of the company's substantial launch, SpaceX has now safely delivered 323 small satellites to orbit for more than 100 customers, with just 3 dedicated transporter missions. SpaceX is planning up to 3 more dedicated rideshare launches this year: Transporter 4 in April, Transporter 5 in June, and Transporter 6 in October. Virgin Orbit's LauncherOne orbital launch vehicle has successfully lofted 7 tiny satellites into orbit on January 13, marking the third successful mission for the Virgin Galactic spin-off company. LauncherOne and its 747 carrier aircraft Cosmic Girl took off from the Mojave Air and Spaceport on Thursday afternoon before flying out to the launch zone near the Channel Islands off the Southern California coast. Cosmic Girl carried the fully fueled LauncherOne rocket under its left wing, attached to a pylon that uses a hardpoint built into that wing. After Cosmic Girl and LauncherOne reached the intended launch zone over the Pacific, the 747 completed a circuit around the zone while the rocket systems were checked out. Once all systems met launch criteria, the crew aboard Cosmic Girl proceeded to the launch point and released LauncherOne. Seconds after the drop, LauncherOne ignited its first stage Newton 3 engine, which uses liquid oxygen and RP-1 as propellants. The rocket climbed on its southeast-bound trajectory before stage separation around a T+3-minute mark. The second stage, using a similarly fueled Newton 4 engine, ignited shortly after stage separation to place the payloads into the intended orbit. The flight, dubbed Above the Clouds, carried the 7 satellites to a 500-kilometer circular orbit, inclined 45 degrees to the equator. 4 of the satellites were provided by the Defense Department's Space Test Program, 2 from Polish small-sat developer SatRevolution, called Stork 3 and SteamSat 2 satellites. The 7th payload, Adler-1, built by Spire Global, was added relatively late in the planning for the mission, which Virgin Orbit said was a demonstration of its responsiveness. So far, Virgin Orbit is averaging about 6 months between launches, but the company says that they are targeting 6 launches this year, which would double the launch cadence. The moon had long been thought to be totally dry, but many orbital observations and sample measurements completed over the past decade have confirmed the presence of water on its surface. However, no in situ measurements have ever been conducted on the lunar surface. But recently, China's Chang'e 5 lunar lander has found water on the surface of the moon, marking the first ever time scientists have found on-site evidence of lunar water. The Chang'e 5 probe launched on 23 November 2020 consists of 4 modules, 2 of which remained in lunar orbit. The other 2, the sample collector and an ascent vehicle, landed on the moon on December 1, near a massive mountain called Mons Rumker. Within hours of landing, Chang'e 5 swiftly got to work, operating its scoop arm to collect samples from the moon's surface. On December 3, just 2 days after landing, Chang'e 5 placed its samples in the ascent vehicle, which then launched from the moon's surface back to lunar orbit. The module docked with an orbiter on December 5, and the lunar samples were passed to a return capsule on the orbiter. On 16 December 2020, the capsule, containing around 2 kilograms of drilled and scooped lunar material, landed in Inner Mongolia. However, before sampling and returning the lunar soil to Earth, the Lunar Mineralogical Spectrometer on board the lander performed spectral reflectance measurements of the regolith, thereby providing the unprecedented opportunity to detect lunar surface water. In a study published in Science Advances, Chinese researchers claim the lander detected signs of water molecules or hydroxyl, a close chemical cousin of water. It found that most of the soil had a water concentration of fewer than 120 parts per million, making the surface of Luna much drier than that of the Earth. Chinese scientists believe most of the molecules came to the moon through a process called solar wind implantation. It is a phenomenon in which charged particles from the sun drove hydrogen atoms to the lunar surface, where they later bonded with oxygen to form water and hydroxyl. Chang'e 6, China's next lunar sample return mission, is set to launch in 2024 to collect samples from the moon's far side. NASA's Perseverance rover recently hit a snag while trying to capture its latest piece of rock from Mars, with a pebble-sized bit of debris stopping it from storing the sample. Last month, the Perseverance rover successfully cored and extracted a sample from a Mars rock. Everything went smoothly until Perseverance transferred the sample, which was already inside its titanium tube, into the bit carousel, a rotating wheel-like structure on the rover's chassis. Sensors recorded resistance unexpectedly early during this step, suggesting a blockage of some sort. The team commanded the rover to take more images to study what happened and how it could be fixed. The latest photos that arrived last week showed that during the transfer of the bit that contains the sample into the rover's bit carousel, fragments of cored rock fell out of the sample tube. This prevented the bit from seating completely in the bit carousel. According to NASA, the designers of the bit are currently planning necessary actions to remove the debris in the bit carousel in a controlled and orderly fashion. This isn't the first sampling challenge that Perseverance has faced on Mars. For example, the rover failed to collect any material during its first sampling effort, which took place in August 2021. The mission team determined that the target rock on that occasion was likely too soft, crumbling to bits, that didn't make it into the tube. NASA's InSight lander, which landed on Mars in 2018 to study the red planet's inner structure, has entered safe mode after a regional dust storm reduced the sunlight reaching its solar panels. The agency stated that all but the most critical functions of the lander had been suspended since January 7. According to NASA, the mission's team re-established contact with InSight on January 10 and found that it had a steady supply of power and was unlikely to run out of power. Ever since the lander touched down on Mars, it has had continuous encounters with dust that accumulate on its solar panels and reduce the power supply. Dust storms can affect solar panels in two ways. Dust reduces sunlight filtering through the atmosphere, and it can also accumulate on the panels. As for the current storm, the agency said it remains to be seen if it will leave an additional layer of dust on InSight's solar panels. Until now, InSight has resorted to an innovative way for shedding off the dust to gain some energy, using a scoop on its robotic arm. Interestingly, whirlwinds and gusts of dust storms, while they reduce the power supply, have also helped to clear solar panels of rovers and landers in the past. However, NASA says that none of them have cleared the panels on InSight, even though its weather sensors have detected many passing whirlwinds. Scientists are waiting until next week, which they believe will be the perfect time to rescue InSight from the safe mode. Now, let's discuss some of the major Starship updates from the past week. Last week, SpaceX literally took the Starship rocket catching arms to new heights. On Sunday afternoon, January 9, SpaceX initiated a new and major round of chopstick tests. Instead of lifting a few dozen meters and performing basic actuation and coordination tests, as they did 2 weeks ago, SpaceX simply lifted the arm assembly up along the tower's exterior to its top. There were a few brief pauses, but the arms eventually reached the approximate height required to stack a Starship on top of a super heavy booster. Despite being designed to catch boosters and ships in mid-air, the arm's primary function is to safely, accurately, and precisely lift and stack Starships and super heavy boosters. SpaceX could obviously use a giant crane to accomplish a similar feat, but such large and tall cranes are extremely sensitive to strong winds and thus become extremely dangerous to operate in windy conditions. Once the arms reached the top of the tower, SpaceX conducted several swing tests to simulate the movements that would be used to carefully lift Starship, swing it over top of Super Heavy, and make the 2 stages. Finally, the tower appeared to finish the simulation without any major issues. According to Musk, the catching arms are designed to have less than 1 hour turnaround time. Prior to the lifting test, SpaceX installed a temporary frame connecting both arms of the tower to simulate a Starship or Super Heavy booster. That frame raised the stakes for the longitudinal actuation portion of the testing on January 9, as anything less than a precise and synchronized movement of both arms could have resulted in the heavy steel frame falling hundreds of feet down. 2 days later, on 11 January, SpaceX installed 6 water bags, 3 to a side, on the Starship simulator frame. These bags, which resemble giant heavy-duty water balloons, are routinely used to stress test large structures and devices by simulating payloads that would otherwise be too expensive or inconvenient to use solely for testing purposes. The bags SpaceX employs were built by Marine and Industrial Solutions, and they have a maximum capacity of 100 tons each. Filled from the bottom with pumps, they are commonly used to test mobile cranes and cranes inside buildings or on board ships and even offshore rigs. With those seemingly empty bags attached, SpaceX proceeded to move the catching arms up and down the entire length of the launch tower at breakneck speed, climbing and descending 120 meters in about 7 minutes, averaging a brisk 1 kilometer per hour. The next day, SpaceX filled the bags with water to test the strength of the robotic arms. SpaceX appeared to have almost completely filled 4 of the 6 bags and partially filled the other 2, resulting in a combined mass of around 500 tons. The dry mass of a Starship is approximately 120 tons, and that of a super heavy booster is about 200 tons. Given that the launch vehicles may have some leftover fuel during mid-air capture, filling the water bags with around 500 tons of water is more than enough for simulating the mass of the launch vehicle, with an added safety margin to account for emergencies, unexpected loads, misuse, or degradation. In the late afternoon, the catching arms were lifted around 10 to 20 meters and rotated left and right, partially demonstrating the process of rotating a lifted Starship or Super Heavy into position for stacking or launch mount installation. The water bags were removed from the catching arm after tests. But since SpaceX has not yet raised the catching arm to the top end of the tower with filled water bags, they may reinstall the water bags and test the catching arms in the coming days. According to a recent letter to the U.S. Federal Communications Commission, submitted on January 7, SpaceX revealed that Starship could be ready to launch Starlink Gen2 system satellites as early as March. The next-generation Gen2 satellites are part of SpaceX's Starlink constellation that aims to provide high-speed broadband internet service globally. In August last year, SpaceX submitted an amended application to the FCC that included 2 proposals detailing how the company planned to launch the Gen2 system. One of the proposals, Configuration 1, states the company could complete Phase 1 of the satellite constellation by using Starship when the launch system is ready. The Configuration 2 proposal is an alternate arrangement that would continue to be launched by Falcon 9 if the Gen2 satellites are ready before the Starship launch system is operational. However, the FCC told SpaceX it could only select one configuration. On January 7, SpaceX responded to the FCC, stating that the company has exceeded its own expectations in the pace of developing both its Gen2 satellites and its Starship launch vehicle. Accordingly, SpaceX notifies the Commission that it will pursue Configuration 1 and abandon Configuration 2 proposed in the amendment, and the company plans to have Gen2 satellites prepared for launch as soon as March 2022. SpaceX currently has FCC approval to deploy more than 4,000 satellites to an altitude of around 550 kilometers and has launched nearly half of them to date. The FCC has not yet approved SpaceX's plans for the larger second-generation constellation. SpaceX asked the FCC to expedite approval now that it has settled on the Starship-optimized Starlink Gen2 configuration. Even though SpaceX said it could start launching the Gen2 system as early as March 2022, that target date will almost certainly slip, given SpaceX is yet to conduct an orbital flight demonstration of a Starship. The test flight is expected to happen as early as March after the Federal Aviation Administration completes its review of the launch site and grants the Starship craft a launch license. Moving on to other Starship updates, at the launch site, the orbital launch mount is being prepared for the orbital test flight. A launch mount venting test was conducted on January 9, and a full speed booster quick disconnect mechanism test was conducted on January 15. The Super Heavy Booster 3 prototype has been completely dismantled and removed from the suborbital launch pad B. Work on the orbital launch tower is still ongoing. Workers are currently working to add a roof to the structure. At the build site, the methane downcomer was installed into Booster 7, which is currently inside the high bay, and the forward sleeve of Booster 8, with openings for grid fin installation, was spotted for the first time. With this, we have covered all the major updates from last week. Please share your thoughts on the latest science news and Starship updates in the comments section. Also, do not forget to subscribe to the channel for more weekly updates. And as always, thanks for watching.